Alright, so let's take a look at the coding results. Before we start with the coding results, in the previous videos I showed that one-dimension convolution, the dimension is basically along the temporal axis. So this is your temporal axis, time. And then you could have a filter, in this case 2 dimensions, and you slide the filter down, right? But you need to convert these words into vectors, yeah? So that's why we will have an embedding layer when we use 1D convnets on text, yeah? So just want to give that with you. Alright, so we applied a series of models on the Jena dataset and tried to predict temperature 24 hours ahead. And we did a baseline using a simple GRU where your error was 0.28 but increasing. It went immediately into overfitting. Yeah? Of course it was fast, but not so very good. And then we added dropout and recurrent dropout to the GRU layer, and suddenly the absolute error, is between 0.29 and 0.31. No overfitting, although we could see a slight tendency after epoch 25, yeah. And of course it's also fast. Fast and slow are relative terms. This means fast and fast compared to this one. Yeah, so this is not absolute. This is compared to this one. So I will write here versus. Yeah. So added stacking, you see that the stacking, but we keep the dropout. So we put actually 2 GRUs on top of each other. And we see that the loss here is quite under control, but still around 0.28, 0.29. But there's no overfitting. Again, we have the dropout here, but this one is quite slow. We see if we stack GRUs, speed is going down significantly. And then we looked at the bidirectional case. Yeah, here you see that the error is quite under control, between 0.28 0.3. There's no overfitting, although there is some tendency to go slightly up above epoch 20. Yeah, I don't want to play here with fast and slow because it has no meaning here. Yeah. All right, and then we looked at the IMDB dataset. Why? Because we wanted to make the case that a 1D convnet will be faster and as good as an LSTM on this dataset. Because the global order doesn't mean that much. You look for sentiment-bearing words. However, the result is not what we expected. So our LSTM, and this was an exercise we did in a previous chapter, gave an error of 0.33 to 0.35 without overfitting. But of course it is slow compared again to the 1D convnet. Yeah? So here again versus. But this 1D convnet, overfits and quickly the validation error goes through the roof. And this is a little bit counterintuitive because we would expect that a 1D convolutional net would do well in this case. So I'm a bit puzzled on why it's not the case. And if you're going to the coding exercise and you find it, you find that maybe we made a mistake, let me know. Drop me an email. And then at the end we used the Jena dataset again. So this dataset, the same. And we tried a blended model that would actually take the benefits from the one-dimensional convnet, meaning mainly speed, and the benefits from a GRU, which is mainly awareness about global order, So we wanted to combine speed with awareness of global order, and we got an error between 0.28, 0.32. No immediate overfitting, but there is a slight uptrend from epoch 7.5, and obviously it is faster compared to I would say these ones. Yeah, here as well, faster. I would actually take it away because it's not that outspoken in my opinion. Alright, so with this we finish the long chapter on natural language processing and recurrent neural networks. See you next time.